Hello class, welcome to Pre-Algebra Lesson 11.6, which is all about scale drawings. By the end of this lesson, you should be able to use ratio reasoning to find actual lengths and areas from scale drawings and reproduce a scale drawing at a different scale. Okay, so let's talk a little bit about some vocabulary. So there is, you can see on this slide, it is the Eiffel Tower located over in Paris, France. And you can see on the left that this is what the Eiffel Tower looks like in real life. Right next to it, you can see a drawing. Maybe you've seen drawings like this. You can see it's on blue. It has some like little measurements listed to it. That's sometimes we call these like blueprints, but this is a form of what's called a scale drawing. And the reason it's called a scale drawing is because this drawing isn't actually the same size as the Eiffel Tower, right? That would be a ridiculously large drawing. So sometimes what we do is we take things that are going to be so big that we shrink them down so we can fit them on a piece of paper. And we do that by keeping things proportional and coming up with what is called a scale factor. Okay, so this here is a scale drawing. And then next to it, there's something called a scale model. So a scale model is a 3D representation of something in real life. So you've maybe seen like little statues of the Eiffel Tower or like keychains or whatnot. Those are usually like a scale model. It's a different size of an existing object, okay? Some other really common scale models would be like model cars, model airplanes, sometimes rough ideas like when you make something out of Legos that's just like, you know, something that exists in the real world. And another real world example of like a scale drawing, like I mentioned earlier, like blueprints for like maybe a house or a new monument or skyscraper or something. But then there's also maps that are forms of scale drawings, and you'll see that actually in our first example. Okay, so we're going to use this map in order to use scale drawings to find length. So use the scale of the map to find the actual distance between Hagerstown and Annapolis. The distance between the two cities on the map is 4 units. Okay, so if we look at this, you will see something located on a map, usually in the bottom corner. Sometimes, so I guess it's not always bottom, but usually in a corner somewhere, you will find something called the scale. And so what the scale means is you can see like this distance right here. On the map, it's called 1 unit. So I'm going to say 1 unit. And we see that 1 unit is equal to 24 miles. So 1 unit is 24 miles. So then, if I want to use this map to figure out how far apart are these two cities, what I would do is I would say, okay, well, if you measure out on the map, you'll see that it's 4 units. So then I want to figure out how many miles is 4 units. So this is where you do something called cross multiply. So I would do 1 times x. Okay, so I do 1 times x, which is just 1x, or just x, equals, and then you would do 4 times 24. So x equals 4 times 24 is 96. So I know that those two cities are 96 miles apart from each other. Okay, and that's all I have to do for this problem. So why don't you do something that's really similar and use the scale of the map to find the actual distance between Clarksville and Little Rock. On the map, the distance between Clarksville and Little Rock is 4 units. Good luck. Okay, hopefully you ended up with 80 miles. You would set it up like this where you'd put 1 unit over 20 miles equals, and then we have 4 units over x miles. Then you cross multiply, so 1 times x is just x equals, and then 4 times 20 is 80. So that's how I arrived at 80 miles. Okay, now we're going to do we're going to use scale drawings to find area. So if we look at this drawing, you can see that we have a lot of rectangles. And the way we find the area of a rectangle is you do length times width, okay? So in this case, I'm trying to find the actual area of bedroom 3, which is 3 inches by 4.5 inches. And I want to figure out what is that in feet. So if I were to first convert my 3 inches, I would say 1 inch equals 3 feet, or 1 inch over 3 feet. So I got that from right here. Equals, and then my drawing says that it's 3 inches by over x feet. So then I cross multiply. 1 times x is just x. 3 times 3 is 9. Okay, so I know that that one is 9 feet. So actually, let me switch back. So I have 9 feet. And then over here, I'm going to say I still have that 1 inch goes along with the 3 feet. And then I have 4.5 inches. And I want to know how many feet 4.5 inches are. So 1 times x is just x equals 3 times 4.5 is 13.5 feet. So this is 13.5 feet. And then my last step is going to be to multiply those two numbers together. So I say 9 times 13.5 equals 121.5 feet. And then since it's area, we say squared. So that would be my final answer. And I need to make sure I label my answer. Okay, so what I did was I converted each of the measurements, and then I multiplied those new converted measurements to get my area. Okay, so why don't you go ahead and try finding what is the actual area of bedroom 1. We still know that 1 inch equals 3 feet. Okay, so bedroom 1 is located right here. Okay, so go ahead and solve that. Good luck. Okay, for this problem, hopefully you first converted the 3 inches into 9 feet, and then the 3.25 inches into 9.75 feet. And then you took 9 times 9.75 to find that the area was 87.75 feet squared. If you have any questions about this problem or anything else, please be sure to reach out for some help. I am happy to help you. Have a great day.